So hello everybody, welcome once again to Spacelink's Google Hangouts, and today we're going to be talking to some primary school students about our solar system, so the place we called home. So if you just bear with me, I'm going to share my screen. Here we go, and then you let me know if you can see my my presentation. There we go. How's that?
Yeah, we can see it.
Yeah, brilliant. Let's start the slideshow. Okay, so our solar system. So, as I understand it, the students have been already looking at some stuff with the solar system, right?
Yeah, we've been doing a little bit of researching and seeing what we can find out, haven't we?
Okay, yes. Fantastic. So, who can tell me how many planets there are in our solar system?
George?
8.
8 planets in our solar system, did you say? Okay. What do you think?
Agree with that?
Thumbs up if you agree with George. Are we getting a lot of thumbs up?
Okay, brilliant. So does anyone know why that number might have been different in the past? When I was at your age, it was a different amount of planets. Does anyone know any stories about that?
Freya?
Before, Pluto was a little bigger, but now it's quite small, so it's now a dwarf planet.
Okay, so do you think that Pluto has changed its size, and that's why not?
Well, I don't really know, but I think it's people just didn't change it before.
Okay, so you're saying that Pluto used to be. Does anybody know why there might have been a change with Pluto? James?
It was because I think it was 2016. They claimed it a dwarf planet because it was a bit too small.
Okay. Did you hear that, Jacqueline?
Yes, I did, yeah. So those are really good answers, and yeah, that is partly true that Pluto is pretty small and smaller than people thought it was. So originally, when people were tracking the planets, we've known about the planets for a really long time, but we could only see those as sort of closest to us. And if you go out in the night sky, you'll be able to see bright lights that look a bit like stars, but they don't twinkle. They seem like steady lights. And often you can think it's a planet, but it's actually an aeroplane light, or a satellite. So if you watch it and see how fast it moves, if it moves quite quickly, it's probably a satellite or an aeroplane light. But if it's a steady, bright light that doesn't twinkle, that's often a planet. And if you go and have a look online about what's in your night sky, you can see Venus and Mars and Jupiter quite often shining in the sky. Mars will even look a little bit red if it's close enough. So people knew that there were planets since ancient times, and the word planet comes from the word wanderer, because unlike the stars, which appear fixed in our skies, the lights that were the planets moved around, so they called them wanderers. And then once we developed telescopes, we could see other lights moving in the sky, and so we discovered more planets further away. And they were expecting to find another big planet right on the edge of the solar system. And sure enough, they saw a light moving very slowly in the distance, and they thought it would be another great big planet. And so they called it Pluto. And for a long time, we didn't know much about it. But once we got out and had a closer look at it, we realized it was pretty small. And in fact, it wasn't alone. There were lots of other little round, rocky planets out there. And so it's not so much that Pluto's too small, but if we say that Pluto's a planet, then we'd have lots more planets. We'd have tens or even hundreds of planets. There are large objects out there in the outer solar system in a region called the Kuiper Belt where Pluto lives that are more massive than Pluto. So we'd end up with a lot more planets. And so they decided to change the definition. In 2005, the International Astronomical Union had a meeting and decided that one of the things that would make something a planet would be that it's round, which Pluto is. Another thing would be that it orbits the sun, which Pluto does. But the third thing is that it would clear all the area around it of all the debris. That it would have enough gravity to have sucked in all the loose rocks and things around and leave a pretty clear path around it. And that's something that all 8 planets in our solar system do, but Pluto doesn't. It hasn't cleared its neighborhood of debris. And so that is what makes Pluto a dwarf planet. And there are other dwarf planets too, and I've got a picture later of a dwarf planet that's a bit closer to home that also, like Pluto, used to be a planet and lost its status a long time ago. So let's get started. I'm just going to play a little video here. Hopefully you can see that moving. And this is arguably the most important part of our solar system, our sun. So as you can see, it's got a lot going on. It's very dynamic. It's changing all the time. You might have seen pictures online of sunspots. You get these dark spots moving around. Here we've got some nice solar flares going on. and it's full of energy, and obviously it's responsible for bringing us all our warmth through sunlight. It feeds our plants through photosynthesis. All of the energy that we use in anything we burn, like wood or coal, that actually comes from the sun's energy having gone into the plants when they were alive, and then the wood being burnt, that energy you're releasing is originally from when the sun gave that energy. So with the exception of nuclear energy or geothermal energy from underneath the surface of our planet, all of our energy really comes originally from the sun, even if it's been trapped in oil or coal for many thousands or millions of years. So the sun's really, really important. And also it's the sun that keeps us all orbiting around it and keeps us nice and warm. So we'll move on a little bit to our solar system now. So here we've got a picture of our 8 planets. And I'm wondering if anybody knows about this line here, that imaginary line that we could draw between Mars and Jupiter. Does anyone know if there's any difference between either side of this line, or if there's anything in this space between Mars and Jupiter?
So what do you think, Ben?
Well, in between them there's a big asteroid belt.
The big asteroid belt. And can you tell everybody what the asteroid belt is?
Well, it's basically like a giant circle full of asteroids.
Okay.
Yeah, that's brilliant. That's exactly right. So the other thing is that on one side of the line, we refer to these planets closer to the sun in our solar system as terrestrial. Does anybody know what terrestrial means?
Anybody know what terrestrial is? Jack, what do you think?
Does it mean rocky?
Does it mean rocky?
Yeah, you're right that in this context they do mean rocky, but the word terra actually means earth. So you might have heard the words like terraform when you go to another planet to try and grow plants and stuff and make it more like earth. And you hear in French, the French word for a potato is pomme de terre, which means potato of apple of the earth, which is a potato because they're similar textures. So you hear this word terrestrial, we hear it about terrestrial TV, and what they mean is earth. And so in this context, you're right that they mean rocky like Earth. So this side of the line, we've got Mercury, Venus, Earth and Mars, which all have solid rocky surfaces. And so this is Earth-like. What about on the other side of the line? Does anyone want to guess what kind of thing they've got in common on the other side of that line?
Lucy?
They all made of gases.
That's a fantastic answer. Well done. So these ones are known as the gas giants. Sometimes you'll hear Uranus and Neptune referred to as ice giants, because they've got a higher proportion of icy stuff in their atmospheres. But yes, they are gassy. And so they don't have a solid surface like Earth or Mars. And so if you were to go there and try and step on the surface, you'd fall into it. And they're very big and massive. And so I wouldn't fancy going there for a walk there. You'd probably get squashed very quickly. And going just back to what you were saying about the asteroid belt being a big circle of asteroids, that's exactly right. So in between Mars and Jupiter's orbit, you've got this big collection of millions and millions and millions of rocky sort of potato-looking asteroids. They're not round, but we'll come back. Actually, there is one that is pretty round in the asteroid belt, which comes under dwarf planet, and I'll show you a picture of that a bit later when we get onto the rest of the solar system. So, Mercury. Does anyone want to tell me what they know about Mercury?
Right, let's have some Mercury facts. Come on, Freddie.
There's actually no air or anything in Mercury.
Okay, Emma?
It's the closest planet to the sun.
George?
One side of it's hot and one side of it's cold.
Okay, yeah.
It's the fastest to orbit the sun.
Fastest to orbit the sun. Fred?
One day is 58.6. Like that's about 3/4 of its orbital period.
Okay, so that's the length of a day. Owen?
It's the smallest planet in the solar system.
Okay. Emily?
It takes over 88 days to circle around the sun.
Over 88 days. Just have one more. Jessie?
It's as wide as the Atlantic Ocean.
It's as wide as the Atlantic Ocean. Oh, that's an interesting fact. Okay, what do you think to our facts, Jackie? Were we right?
I don't know what else I can tell you about Mercury. That's a brilliant research. There's obviously a lot of work gone into that. So those are loads of facts about Mercury. And I'm really glad to hear that, because Mercury gets forgotten quite a lot, because it is quite I don't want to say boring, but it doesn't do much compared to a lot of the other planets. A lot of people forget about it, but actually there's been some really nice missions to Mercury. If you're interested in the history of exploring Mercury, you can look up the Messenger mission. And actually we very recently had a launch of a mission. Does anyone know the name of the mission that was launched at the end of last year to go to Mercury?
Anybody know the name of it? Lewis? No? Any guesses? Ben?
My guess is just Mission Mercury.
Mission Mercury. That would be a good name.
Not a bad name at all. And in fact, the Messenger mission was called Messenger because Mercury is one of the messenger gods. So you're right that they do tend to name them after the sort of planet. But there's a mission called Bepi Colombo that just launched at the end of last year. And that's going to go there, and it's going to do some flybys of Venus as well, and then it's going to fly past Mercury a few times and eventually go and study it. And that's all going to be happening over the next sort of like 5 years. So it's a really good time for students of your age group. You'll be able to follow this mission in real time and see the data coming back. And I find that when I think back to my childhood days, the missions that were actually going on then were the ones that really captured my imagination. So Bepi Colombo is one to really look out for, and it's great to see us going back to Mercury to find out a bit more about it. Now, interestingly, the surface of Mercury here, you can tell quite a lot about a planetary surface by what it looks like. And this looks very similar to our moon, I think. You know, you've got a lot of these craters here, plenty of craters overlapping each other. You can see some of these sort of like sort of stripy things coming out here. These are rays from where there's been an impact on the surface and it's thrown out material. And it tells us something about the age of the surface. So if you have a surface that is very old and you, as somebody said there, you don't have an atmosphere and you don't have wind and water and air blowing stuff around, you get a really nice preserved surface of the history of what's happened. And so we can tell that Mercury's surface is quite old, which means it probably doesn't have anything renewing the surface like we do on Earth. And we'll come back to that in a little bit. So how many craters you can see on the surface tells you a little bit about the processes and dynamic features on the planet. So moving on to Venus, what can you tell me about Venus?
Come on then. Who haven't we heard of yet? Noah?
It's the hottest planet in our solar system.
Hottest planet. And James? Have you got something to tell us, Ellie? Second planet from the sun, thank you.
Carbon. Venus's atmosphere is made of carbon dioxide.
Oh, interesting. Yeah, Olivia?
Without special protection, a visitor to Venus would instantly die, and they would be burned to a crisp by the scorching heat and discovered by the acid.
Nice. That's nice. Nice fact. Freya?
I know why Venus is hotter than Mercury when Mercury's close to the sun.
Oh, that's
because Venus has an atmosphere and Mercury doesn't. So Mercury can't trap the hot air in its atmosphere, and Venus can.
Oh, I like listening to that. Harvey?
There is no oxygen or water on Venus because, well, it's actually it's not the first hottest planet on the solar system. It's actually the second. Because if you would have flown to Mars, then you would literally die instantly.
Okay, so you listened a little bit to Freya there too. Let's have one more. Tilly?
The temperature of Venus is 465 Celsius.
That's quite hot then, isn't it? Yeah. Okay.
Oh, that's fantastic. All really good facts. And so, yeah, the key thing about Venus is that it has this really thick atmosphere. And Venus, we often call it our sister planet because it's about the same size as us. And it has an atmosphere like we do. And as somebody said there, the reason it can get even hotter than things that are right next to the sun, like Mercury, is because of the greenhouse effect, the gases in the atmosphere that trap warmth inside. I mean, we're really grateful for the greenhouse effect on Earth because it keeps our temperature nice and regulated, and it means that we can stay warmer than we might otherwise. And obviously our atmosphere gives us oxygen. But Venus is a really good lesson for why we need to be very aware of the amount of carbon dioxide and other greenhouse gases that we put into our atmospheres, because Venus is an extreme example of when you get a runaway greenhouse effect. Earth has quite a well-regulated greenhouse effect where our atmosphere traps just the right amount of warmth and keeps the amount of energy here that we need. And we have to be very careful that we respect our environment. And what we don't want to do is pump too much carbon dioxide and other greenhouse gases into our atmosphere and end up with a runaway greenhouse effect. So the greenhouse effect is very important, and for Earth is a really good thing, but we need to make sure we take care of it. The other thing about Venus's really thick atmosphere is that it means you can't really see what's going on the surface because it's too cloudy. And somebody mentioned there about you wouldn't want to go to the surface, you'd die instantly. And this poses a real challenge for trying to look at the surface of Venus, because we have sent landers there. The Soviet Union sent landers to the surface of Venus, and the temperatures are extremely high. It's a horrible, choking, thick atmosphere. The pressure is really high. So anything you send there doesn't last very long. And I urge you to go and look up the Venera missions to Venus to have a look at some of the engineering that goes into trying to build something that's strong enough to land in that atmosphere and stay alive on the surface there to take readings for us. But fortunately, there's another way to look at the surface. Does anybody know what technology might we use to look through the clouds of something?
Lucy?
Telescope.
Telescope. Any other ideas? Yeah.
Ray vision.
X-ray vision. Yeah, Amelia?
Would you use a satellite?
Satellite. Any other ideas? Emma?
You were talking about that iPad app the other day.
Use an iPad app. Okay, a few ideas there.
I mean, there's all fantastic ideas. And so, yeah, what you do need to do is you need to send a satellite there. You need to use images to have a look at it. And somebody mentioned X-ray vision, and actually it's fairly similar, a slightly different part of the electromagnetic spectrum. So when you go to the hospital and I think you might have broken a bone, or they want to look at your lungs or something, they'll use X-rays because it can look through the surface of something. And we have a similar thing we can do. We can use radar to look through the surface. So we use radar to image all sorts of things. You can use it on Earth to image below sand if you want to try and see what's below the desert. You can use radio and X-rays, radar waves, microwaves to look through clouds. And so this is really useful for us. And so this is an example of what you see when you use radar imagery to look through the surface of the clouds and have a look at the surface. We found out a lot about Venus's surface. We can see that unlike Mercury and the Moon, it looks pretty clear of craters, but you have other features there that, I mean, they look like they could be sort of rivers or cracks or something. But what we think this is because of volcanic activity. We think that the surface was very hot and there was a lot of interior heat there, and you had a lot of molten rock rolling about on the surface and all these little domes and pancakes and spidery looking things. And we think this is because of volcanic activity on Venus. Whether or not that continues today, we don't know. And Venus is still a little bit of a mystery, precisely because we can't send satellites around it to take nice visible image pictures. We have to rely on technologies to try and get an image of the surface. So Venus is a really cool one, but very difficult to visit. And unlike Mars and the Moon, I think the ability to put people on the surface is maybe something we'll never be able to do, at least not without very good technology, similar to what we might use to go to the bottom of the ocean on Earth to protect the astronauts, because a spacesuit is just not going to cut it on Venus. Earth. So a lot of people have favourite planets, and, you know, I often say Jupiter or Mars for my favourite planet. But really, I mean, it should be Earth, right? We all live here. It's fantastic. And it's brilliant. It's got everything we need to survive on it. Does anyone want to tell me what's unique about Earth that the other planets don't have that make it a great place for us to live?
So why is it a great place to live? What's unique about it? Let me see. You've not heard of Josie.
Well, it's got like water and greenery and wildlife and that.
Water, greenery, wildlife. Another couple of answers. Sunny.
It has air.
It has air. I'm looking for somebody who's not said something just yet. Think about whether you have said something. Chloe?
its atmosphere is appropriate.
An appropriate atmosphere. Okay.
That's fantastic. All really good answers. So one of the big key things that you mentioned there straight away is the water, liquid water. This is something we do know it does seem to exist in other parts of the solar system, but we haven't seen a planet like this that seems to have this really nice, really stable weather system where you've got liquid water in the oceans, you've got a rain cycle of evaporation and precipitation, which you might have studied. So the clouds can move our water from big bodies of water like oceans and lakes and then rain them down on other areas. Somebody mentioned greenery and wildlife. Us having life here is the only place we know that has anything like it. I mean, even if we find bacteria on Mars or a moon of Jupiter or something, we're pretty certain that you haven't got herds of giraffe running about and people living in cities and, you know, building colonies and stuff. We don't seem to see any evidence for that in our solar system at the moment. So the huge diversity of life we have here is unbelievable. And some other things are important. We've talked about the greenhouse effect already. But also we have seasons here, nice regular seasons. The way our Earth is tipped, we have a pretty equal spring, summer, autumn and winter. It's a fairly stable axis that the planet's on. So we know the North and South Pole are very cold and it's very hot at the equator. But there are lots of regions of Earth that have pretty stable temperatures that don't fluctuate wildly like they do on Mercury, where you're 400 degrees in the one part of the day and then minus 170 on the other. We have a fairly stable area of temperatures that means that wildlife can survive quite well. And of course, that wildlife has adapted to be in those areas. So animals that live in the North Pole will have like thick fur coats or lots of fat to keep them warm, while other animals in the desert will develop thin little legs and can run fast and keep their feet from burning on the surface. And so this is a really fantastic thing we see. The other interesting thing is that Earth is the only place we know of that has a tectonic plate system and has these plates that move around and the continents shift. And this also means you get hydrothermal vents happening in the under the surface of the sea, where you get warm water coming out full of chemicals. And this is one of the places we know that extreme types of life live. They live around these hydrothermal vents and they're able to eat the chemicals that come out of there and have a completely independent ecosystem, even with no sunlight, right at the bottom of the ocean. So Earth really has a lot going for it, and it's not a coincidence that we live here. If it was any different, we might not have evolved. If we were just a little bit too far out from the sun or too close, if our seasons weren't as regular, our atmosphere was a bit too thick or too thin, we might have evolved differently, or we might not have evolved at all. And so this is why searching for other planets is really interesting, because they don't have to be exactly the same as Earth, because life will adapt. But there are some things we think are really important to finding life. And one of those things is liquid water. So that's something to look out for in the rest of our solar system and beyond. So Mars, what can you tell me about Mars? I'm sure you've got lots of Mars facts for me.
Okay, Lottie, can you start us off?
Mars is half the size of Earth.
Thank you. Ben, can you give us a Mars fact, please?
It takes 687 days to orbit the sun.
Owen?
You could be half your age on Mars.
Half your age on Mars. Harrison?
It's possible to live on Mars.
You think it's possible to live on Mars, do you? Okay. Yeah.
It has 2 moons.
2 moons. Lewis?
It has water.
Chloe?
It's known as the red planet.
George?
They found germs on Mars.
Found germs on Mars. Freya?
They have like rovers on Mars.
Oh, there's been rovers on Mars. Yes, Noah?
It's named after the Roman god of war.
Okay. Lots of different thoughts and opinions there.
Although some of those are really interesting. It's interesting. The last student there mentioned that it's named after the Roman god of war, and also somebody mentioned its 2 moons, which are called Phobos and Deimos, which mean fear and panic, I think they mean, and they are the Roman god of war's horses that pull his chariot. And those two little moons are very likely to be asteroids captured from the asteroid belt. So they're not round like our moon. They're like little potato-looking things. And one is getting further away from Mars and might eventually disappear. One is getting closer and closer to Mars and will probably crash into the surface. So their moons are pretty interesting as well, although they are basically little potato rocks. But they're interesting nonetheless, and they tell us a little bit about the early solar system. Somebody mentioned water on Mars. Yes, there is lots of water on Mars, but it seems that it's mostly either in cloud form or frozen as ice under the surface or at the poles. There has been some evidence recently that there might be small areas of liquid water on the surface of Mars, maybe because it's salty and the salt changes the freezing temperature. But largely Mars is pretty dry. There might be some evidence of a little bit of water, but it's very short-lived, and that's still a bit of a controversial subject that's still being investigated. But we think that there probably was a lot of water on Mars. So here you can see some nice close-up images of these features on Mars, and these look very much like features you might get on Earth. Does anyone want to say what they might look like?
What do they remind you of, those images? Emma?
Well, the yellow ones look like a beach.
The yellow ones look a bit like a beach. Harvey?
The droplets are shaped a bit like trees.
Oh yes, but a bit like trees, a bit like roots, do you think? Okay. Harrison?
The like footstep things on the bottom left look like fish.
Oh, a bit like fish, the bottom left. Yeah, Ben?
Well, there's ones across the surface that kind of look like rivers and dried up.
Like a dried up river, yeah. Yeah, one more. Yes, Amelia.
Some of them look like bullets.
Like bullets. Okay.
Well, these are really interesting things you're coming up with here, because, yeah, you're right. So this one up in the top left, it looks very much like some river channels and sort of river deltas that we might get. And someone mentioned the beach, and yes, these sort of sandy things. And you often see when the tide's going out on the beach, on a sandy beach, you might find water running out in little rivulets and leaving these things. Over here on the right, somebody mentioned tree roots. And that's an interesting term you've used there, because this looks a lot like a sort of river delta that you might get at the end of something like the River Nile, where the river spreads out into all these little branches. And we use this tree-like language. We say branches, the same as branches on trees. And the word we use in geology to describe the sort of pattern is dendritic, which means like a tree, so tree roots. So here you can see it looks very much like that. And you see these patterns repeated in nature, things that work well or have a certain physical reason behind them often behave in the same way. And you can see a lot of repetition of patterns in nature between things that on the surface of it don't look particularly related, but actually you see these things a lot. Somebody mentioned these ones down here that are fishes. And it's interesting, somebody mentioned bullets there as well, because this is actually what you call a streamlined island, and that kind of streamlining of something running around it. So you can imagine the water might have come along to hit this crater from the bottom to the top and then gone round and then met up again. And you get left behind with these streamlined things, much like you might get behind a plane or behind a bullet. And yeah, you get left with these behind. Over here on the bottom right, we've got some gully-looking things that might have eroded out. And so there's lots of evidence that there has been large amounts of liquid water in the past, and not just rivers, lakes as well. So that's all really interesting stuff. And it does mean that even though Mars is pretty dry now, it used to be quite wet, and probably at about the same time that life was first evolving on Earth, about 3.5 billion years ago. So if life evolved on Earth, is it possible that maybe life started evolving on Mars and then just came to a stop? Maybe it's extinct now, or maybe there's bacteria under the surface. Somebody mentioned about finding germs on Mars. We haven't found any evidence of any bacteria or germs yet, but we have found some organics and other basic building blocks of life, and we've never really got a chance to look that deep under the surface. The surface of Mars has lots of radiation on it. It doesn't have an ozone layer, which is another great thing Earth has, which protects us from ultraviolet radiation and stops us getting sunburned. And Mars doesn't have that. So it's possible that we might be better off looking under the ground. So one of the things we want to do is go and drill a hole, and that's what the ExoMars rover is going to do when it goes to Mars soon. That's going to drill a 2-meter hole, borehole, and then have a look at the material from there to see if it can find any evidence of life. Someone else mentioned about living on Mars. You could live on Mars. Well, that's definitely something that people are thinking about for the future. We've already sent humans to the moon. Going to Mars, you could use the same sort of infrastructure to be safe there. You could have your space suits, and you could have little buggies to rove about on like we did on the moon. But the problem with Mars is it takes so long to get to. Will take you a good 5 or 6 months to get there, and then once you were there, the planet would have moved in relation to Earth, so it would take you even longer to get back. So when we send people to Mars, we need to think about how we might keep them safe out there for years at a time. And so it's a much bigger event to do than going to the moon. The moon is like a 3-day trip, whereas Mars, we're talking years. So we need to really think about making it safe there. I think the next step we'll see is a sample return mission from Mars. We've already done that to the moon. The Russians sent things to go there and bring back rocks, and obviously we sent people to go and collect rocks, but sending robots to go and collect rocks and come back will hopefully be the next step for Mars. And finally, somebody else mentioned rovers, and yep, we've got lots of rovers up there at the moment. Curiosity mission is doing fantastically, and we're going to see the NASA rover and the ExoMars European Space Agency rover going up there soon. So hopefully we're going to have a lot more data for Mars for you to look at over the coming years. Just a little note about the scale of these things. Somebody mentioned that Mars was about half the size of Earth. So here we can see Earth and Venus fairly similar. Then Mars about half the size, Mercury smaller, and then little Pluto on the end. And it's worth just having a think about the scales we're talking around, because when you put next to this our gas giants from that gas giant section of the solar system, look how much bigger they are. So Jupiter is way, way bigger. You can see little Pluto down here on the bottom right. And you can barely see Pluto in those images, let alone Mars. And then there's tiny little Earth, which is smaller than the red spot on Jupiter. Uranus and Neptune a bit bigger. But, I mean, look at the size of Jupiter. And although Saturn is almost as big, I suppose, Jupiter is actually a lot denser, and it's more massive in terms of how much it weighs than all of the other planets put together. You could fit the weight of all of those planets into just Jupiter. And we're thinking, wow, Jupiter's pretty big. But then if you think about what I was saying at the beginning about how important our sun is and the sun's gravity, and then you have a look at how big the sun is compared to Jupiter, the scales are just huge. So,
look at the size of Earth.
That's caused a little bit of excitement there. I tell you what, we'll have to do we'll do a talk soon on the scale of the universe, because if you think our sun's big, there are some stars out there that make our sun look pretty much like Pluto compared to our sun. It's really big stuff out there, and also the distances between these objects are huge. We often see that image like I showed at the beginning of all the planets in a row, but the truth is the gaps in between a lot of these are absolutely huge. So I think what I'll do is I'll make another talk on the scale of the universe if you find that sort of stuff fun, because it really is unbelievable. And so you can see how tiny Jupiter now looks compared to our sun, and what a great force our sun is in every sense of the word, at the center of our solar system. And solar means like the sun or stars. So yeah, that it is the solar system. The sun really is the head honcho. And then again, we are just one little star on the edge of a limb of a pretty ordinary galaxy amongst lots of different galaxies. So studying astronomy is something that can make you feel small, but also it's very important, and it's a real for me it's something that really makes me happy to see our place in the universe. And equally, as much as we're a little sort of tiny planet around a fairly small sun, we've also got this fantastic wealth of beautiful wildlife and beautiful scenery here on Earth, which is pretty unique as far as we know. So onto the gas giant. So here's big old Jupiter. Does anybody know what the red spot is? We know it's bigger than Earth, but what is the red spot?
Harry?
It's a storm.
Storm? Anyone told any more information, right?
It could be like a hurricane or a tornado.
Like a hurricane, tornado. James?
It's been raging for hundreds of years.
Raging for hundreds of years. I like the word raging.
Any more?
Any more? Yeah.
Telescopes show a cloudy atmosphere with colourful belts and spots. The largest feature, called the Great Red Spot, is a giant storm, several times the size of Earth.
So bigger than Earth and a storm. Anything else to add, Lewis?
If you try and land on Jupiter, it's made of gas.
Okay, so thinking just about the spot. Anybody want to add anything about the spot just now? No, that seems to be it.
Yeah, I mean, that's perfect. We think it's a big storm, and you can see these stripes of Jupiter, something we're quite familiar with. And they're basically the cloud tops that you're seeing. And it's similar on Earth, actually. We have these similar patterns called cells. Ours are called Hadley cells on the Earth. And here you have the atmosphere sort of going in one direction, then the one below it goes in the opposite direction. And so you get these beautiful patterns showing where the clouds are interacting and mixing. And they've got different chemical makeups which make them different colours. And yet it seems that this big red spot, and there's other spots on Jupiter, and we see spots on some other gas planets, but this one is really one of the most obvious ones. That's this great big storm that we know has been there for at least 300 years. And maybe one day it'll disappear. We don't know. We don't know enough about Jupiter to know how long that might last, but it's been raging for a few hundred years, and I expect it will be there for quite a bit more. But a lot of the pictures we had of Jupiter were a little fuzzy, and because we'd just done sort of flybys and stuff. But recently there's been the Juno mission, and this is a fantastic image of Jupiter from the Juno mission. And it doesn't look like what we normally think Jupiter normally looks stripy. Does anyone know why this picture of Jupiter looks so different? Anyone? Are you there, Emma? Emma, you still there? Oh, it looks like we've lost Emma for a second. I'm just going to stop the broadcast and hopefully we can get her back.